Alrighty, so in this video, let's talk about linear equations and talk about some practice problems dealing with them. So we'll start with just focusing on independent and dependent variables. So for this first one here, for number one, whoa, what is that? Let's try that again. Okay, number one. I don't know how that got so squiggly. So let's think about the scenario here. So we have the number of cavities, and then we have the number of times that we brush our teeth. Okay, so I'm going to write this just one time, and then I'm going to copy and paste it. Independent variable. Let's see if my pen works nicely today. So independent variable. So we have the independent variable, actually, and then I'll go ahead and write the dependent variable. So, and then I'll just go ahead and copy this each time. All right, so for this first scenario, let's say we have the number of cavities you have, C, and the number of times you brush your teeth, B. Okay, so let's see, the number of cavities you have are gonna depend on how often you brush your teeth. So independently, we're gonna have B, and the cavities will depend. So if you brush your teeth more, your cavities ideally should go down, and if you brush your teeth less, you can imagine that maybe your cavities will go up. So the cavities depend on how often you brush your teeth. For the second one here, let's go ahead and try another scenario. So let's say we have the amount of money you make, M, and the number of hours you work, H. So if you work more hours, you're going to get paid more money. So the amount of money that you make depends on how many hours that you work. Okay, pretty straightforward there. This third one, let's see what scenario we have going on here. Let's say we have the number of miles you run and the number of days you have. So for miles, we'll use M, and for the number of days, we'll use D. So days go by, days will be independent here, and then how many miles you run is going to be dependent on how many days there are going by. So if you have more days, you can run more, okay? For a fourth one here, let's see what we got. For a fourth one, let's say the number of gifts you can make, M, and the number of weeks you have, W. So remember, W is time. That's always going to be independent. If you have more weeks, you can make more gifts. For the gifts, I think I'm using M here, so that depends on how many weeks we have, okay? For number 5, let's check out this scenario. I'm going to go ahead and label this out first. For number 5, let's say the total cost of your food and the amount of food that you buy. Well, you can imagine if you buy more food, it's going to cost more money, right? So the cost of the food, which is going to be F, let's say that's going to depend on how much you buy, B. So F is a total cost, depends on how much you buy. Let's go with a sixth one here. Check out this scenario. Let's say your resting heart rate, R, and the amount you exercise, or that you do, E. Well, if you exercise more and you run or you swim or you do things like that, then your heart rate, your resting heart rate actually goes down. So your heart rate depends on how much exercise you do typically, right? So your R, or your resting heart rate, depends on maybe how much exercise that you do. Okay, so try to stay active. That's 6. Let's check out a 7th one here. For a 7th one, let's see what we got going on. We have the amount of pizza you eat, P, and your happiness, H. So I get not everyone's going to love pizza, but we can imagine that pizza can have an impact on some people's happiness, especially if you're really hungry. So your happiness, we would generally say here, happiness depends on how much pizza you have, right? So if I only give you one little bite of one slice, you might be mad at me. But if I give you a whole bunch, you might be happier, especially if you're just really hungry, okay? I would definitely prefer to have more pizza myself. An 8th one here, let's say the amount you use your laptop, A, and your battery level, B. Well, hopefully, if we think about it, we say, well, if you use your laptop more, then your battery level is going to go down. So your battery level, B, is going to depend on how much you use your laptop, A. Okay, so there's 8 different examples just talking about independent and dependent variables. Alrighty, let's switch gears a little bit here and let's deal with some tables and some graphing now. So let's say we have a linear equation of y is equal to x plus 5. And let's go ahead and create a table together here. So I'm going to go ahead and just make a pretty simple table, nothing too crazy. I think we'll have about 5 values. That sounds about right. 1, 2, that's 3, that's 4. Is that 5? 1, 2, 3, 4, 5. Yeah, I think that's close enough. I'm actually just going to copy and paste this too, so as I go through, it'll be a little bit easier. So this is 0, 3, 6, 9, and 12. And so, okay, if x is 0, what's 0 plus 5? That's going to be 5. If x is 3, 3 plus 5 is going to be 8. If x is 6, 6 plus 5 is 11. If x is 9, 9 plus 5 is 14. And if x is 12, 12 plus 5 is going to be 17. So that would be the data table here that goes along with this one. Okay. In terms of a graph here, let's see how this is going to look. So we're going to need a y-axis over here going up and down. And maybe I'll go across here, something like that. That'll be the x-axis, and then we have 0. So we just need quadrant 1 here. Looks like x is going to go all the way to 12. So I'm just going to call this one 3, 6, 9, and 12. Good enough. And then let's go by maybe 5s here. So 5, 10, 15, and then 20. And so our first point is going to be 0, 5. That's located right here. Then we have 3, 8. I think 8 I'm going to approximate to be right about here. 6, 11. 11 is going to be a little past 10, right? And then 9, 14. 14 is a little below 15. And then 12, 17. It's going to be right about there, okay? So if I draw a pretty rough sketch here, this would be our graph for our linear equation, okay? So nothing too, too crazy, but that would be the table and the graph that would accompany this linear equation. Okay, so that's number 9. Let's move on to number 10 here. Number 10, here we have another one. Let's do y is equal to x minus 2. Okay, so we need another table here, so I'll put x and y. Maybe after this one I'll just copy and paste some stuff too. So there's 1, 2, 3, 4, and 5. That should be good. And then I guess I can make a table, or the graph rather, right now too. Here's the y-axis. Right to there maybe. I'll go a little further. And I don't know, that seems pretty good. Actually, let me copy and paste this right now before I draw on it so I can use this for the next few problems. And let's see what kind of values they give us here. We have 22. 24, 28, 30. Is that it? 22, 24. Oh, I forgot 26, 28, 30. Sorry. So we'll put 26, then we'll put 28, and then we'll put 30. Okay, so if x is 22, 22 minus 2 is 20, right? And then if x is 24, 24 minus 2 is 22. 26 minus 2 is 24. 28 minus 2 is 26. And 30 minus 2 is 28. Okay, so the x-axis, we have to go all the way up to 30. So maybe we'll do 5, 10, 15, 20, 25, and 30. And then for the y-axis, maybe we'll do the same thing actually. 5, 10, 15, 20, 25, and 30. And plotting some points here, we have 22, 20. So 22 is here, and then, whoops, let me try that again. 22, 20, I think that's right about here. And then we have 24, 22, 24, 22, right around there. 26, 24, that's a little past 25, but a little below this 25 over this way. 28, and then 26, it's going to be above over here. And then 30, 28, maybe something like here. So not the prettiest one I've ever drawn, but again, we have to approximate a little bit here. And so we have a linear equation graphed just like this. Okay, so I probably could have been a little bit more accurate, but I think the general idea is that they are approximate, and this is pretty close. Jumping by 5s is a little bit more difficult. Okay, let's go and try an 11th example here, 11th practice problem. For 11, let's try the equation y is equal to 4x minus 7. Okay, and we need a table, and we need a graph. So in our table here, let's go with 8, 10, 12, 14. Oh my goodness, what was that? My pen is just going crazy. 14 and 16 here. Okay, 8 times 4 is going to be 32. 32 minus 7 is 25. 10 times 4 is 40. 40 minus 7 is 33. 4 times 12 is 48. 48 minus 7 is going to be 41. 14 times 4 is 56. Minus 7 is going to be 49. 16 times 4 is 64. Minus 7 is going to be 57. We need to somehow get up to 16 here. So 2, 4, 6, 8, 10, 12, 14. I guess I could do that. I'll go by 4s here. 4, 8, 12, 16, 18. I have to go, oh no, to 57. Let's do 10, 20, 30, 40, 50, 60. Just made it. Okay. 8 comma 25. 25 is halfway between 20 and 30. 10 comma 33. 10's between 8 and 12. I have to go up to 33. It's definitely less than half a box here. 12 comma 41. 41 is a little past 40, just barely. It's a tenth of a box. Then 14 is between 12 and 16. That goes up to 49. That's right below 50. Something like that. And then 16 comma 57. 57's a little past the halfway mark between 50 and 60. And so if I draw a straight line here, again, not perfect, but approximate. If you have a ruler, great. You can make it a little bit more accurate, but this is what the linear equation would look like. Okay, that's 11. Let's try a 12th one here. Let's try the equation y is equal to 2x minus 3. Am I going to be able to fit this here? Maybe, if I move this up a little bit. I want to be able to put some numbers underneath here too. Here, I have an idea. Let's move that one up. Let's move this one up. I think that I should be able to fit everything now. Okay. So for 12, we have this 2x minus 3. What do we have for x values? 7, 11, 15, 19, and 23. And so if x is 7, 2 times 7 is 14. 14 minus 3 is 11. 2 times 11 is 22. 22 minus 3 is going to be 19. Now if x is 15, 2 times 15 is 30. 30 minus 3 is 27. If x is 19, 2 times 19 is 38. 38 minus 3 is 35. Sorry about that. And then 2 times 23 is 46. 46 minus 3 is 43. All right, so let's see, our x values go up to 23. Maybe I'll go by 4s here. So I'll go 4, 8, 12, 16, 20, 24, 28. That's enough for our x's. Our y's go up to 43. So maybe I'll go by 10s, 20, 30, 40, 50. Okay. All right, we're going to have to do some serious estimating here. 7 is close to 8, and then 11 is right above 10. So something like this. All right, 11 comma 19. So 11's close to 12, and then where's 19? 19 is just below 20. So something like that. Then 15 comma 27. 15 comma 27, somewhere around here. 15's below 16 and 27's below 30. 19 comma 35. 19 is right below 20. 35's nice. It's just halfway between 30 and 40. And then finally 23 comma 43. 23 is below 24 along the x-axis. And then 43 is less than halfway between 40 and 50. So, all right, these dots look pretty good, actually. I'm pretty proud of these ones for these approximations. And there's our linear equation. Okay, that's the graph. All right, moving on. So that's number 12. Let's do a few more of these. Do we have enough room to do it? Nah, I don't really want to squeeze it in there if I don't have to, so I have space. I'll go to 13 over here. So for number 13, let's write the equation down. Y is equal to 1/3 x plus 8. Let's get a table going and a graph. That looks good. And let's see what values we want in here. We have 6, 9, 12, 15, 18. Okay, what's a third of 6? A third of 6 is 2. 2 plus 8 is 10. A third of 9 is 3. 3 plus 8 is 11. A third of 12 is 4. 4 plus 8 is 12. A third of 15 is 5. 5 plus 8 is 13. And a third of 18 is 6. And 6 plus 8 is 14. Okay, so our x's are going up to 18, right? So 3, 6, 9, 12, 15, 18. Okay, that works. 3, 6, 9, 12, 15, 18, 21. And our y's go up to 14. So let's see, 2, 4, 6, 8, 10, 12. Nope. Maybe we'll go by 3s. 3, 6, 9, 12, 15, 18. Okay, so 6 comma 10. 10 is a third of a box. 9 comma 11. It's 2/3 of a box. 12 comma 12. That is perfect. 15 comma 13. It's a third of a box up. 18 comma 14. That's 2/3 of a box. All right, looks good enough for me. And that's the linear equation. Okay, there's 13. Let's go ahead and try 14. For 14, what's our equation here? Y is equal to 3/4 x plus 6. So let's give this a go. We need another table and a graph. So for 14, we have 16, 20, 24, 28, and then 32. 3/4 of 16, that should be 12. 12 plus 6 is 18, all right? Yeah, that's right. Okay, 3/4 of 20 is 15. 15 plus 6 is going to be 21. 3/4 of 24, that is 18. 18 plus 6 is 24. 3/4 of 28 is 21, plus 6 is going to be 27. 3/4 of 32 is going to be 8, 8, 8. 24 plus 6 is 30. Okay, our x's go up to 32. Can we go by 4s? 4, 8, 12, 16, 20, 24, 28. No. Can we go by 8s? I think so. 8, 16, 24, 32, and 40. And then, these are going by 3s, aren't they? Let's go by 6s. 6, 12, 18, 24, 30, 36. Okay, so 16 comma 18, that one's nice. 20 comma 21, so 20 is between 16 and 24. 21 is halfway between 18 and 24. Then 24 comma 24, that one's nice. So I chose some good numbers here. And then 28 is halfway between 24 and 32. 27 is halfway between 24 and 30 along the y-axis. Last one, 32 comma 30. These dots actually look pretty good. Cool, that's 14. And let's try another. For number 15, we have y is equal to 5/4 x minus 1. Let's get a table and a graph going here. For 14, or 15 rather, let's go with 4, 8, 12, let's do 16, and then we'll do 20. Okay, so what's 5/4 of 4? That's going to be 5. 5 minus 1 is 4. 5/4 times 8 is going to be 10 minus 1 is 9. 5/4 of 12 is going to be 15 minus 1 is 14. 5/4 of 16 is going to be 20 minus 1 is going to be 19. And then 5/4 of 20 is going to be 25 minus 1 is 24. All right, going along the x-axis here, let's just go by 4s. 4, 8, 12, 16, and 20. And then going along the y-axis, we got to go to 24, right? So that's 4, 8, 12, 16, 20. Okay, 4, 8, 12, 16, 20, and 24 seems to fit. So 4 comma 4, that's a nice one. 8 comma 9. 8, 9, 10, 11, 12. Okay, that's a quarter of a box here. 12 comma 14. 12, 14 is between 12 and 16. 16 comma 19. And then 20 comma 24. Alrighty. There's 15. Okay, there's the graph. Carry on. Let's try 16. For 16, let's try the equation y is equal to 2/3 x plus 4. Let's get our table and our graph. And what kind of values do we have in this table here? 3, 6, 9, 12, and 15. What's 2/3 of 3? 2/3 of 3 is 2. 2 plus 4 is going to be 6. 2/3 of 6 is 4 plus 4 is going to be 8. 2/3 of 9 is 6. 6 plus 4 is 10. 2/3 of 12 is 8. 8 plus 4 is 12. 2/3 of 15 is going to be 10 plus 4 is 14. So I'm just going to go by 3s. 3, 6, 9, 12, 15. And I think we can go 2, 4, 6, 8, 10, 12. That's annoying. Let's go with 2 or just 1 short there. I don't know. I'll go by 4s. 0, 4, 8, 12, 16, and 20. That's fine. Not a big deal. 3 comma 6. 6 is between 4 and 8. 6 comma 8. It's right over here. 9 comma 10. It's right over here. 12 comma 12. Right over here. And 15 comma 14. Right over there. Graphing this would look something like this. All right, there's 16. Let's try another 17. Oops, I forgot to write the equation. I'll write that in a moment. What's our equation for 17? Y is equal to 1/2 x minus 3. And so let's go 6, 8, 10, 12, and 14. Half of 6 is 3. 3 minus 3 is 0. Half of 8 is 4. 4 minus 3 is 1. Half of 10 is 5. 5 minus 3 is 2. Half of 12 is 6. 6 minus 3 is 3. Half of 14 is 7. 7 minus 3 is 4. So let's see. We can do 2, 4, 6, 8, 10, 12, 14. Okay. 2, 4, 6, 8, 10, 12, 14. 1, 2. Just do a 1, a 2, a 3, and a 4, and a 5. 6 comma 0 is right over here. 8 comma 1 is here. 10 comma 2 is here. 12 comma 3 is here. 14 comma 4 is here. So this one's going to come up from there. Okay, that's 17. One more of these lovely graphs. Let's put 18 here. And let's do the equation y is equal to 2.3x plus 6.1. All right, so we have our lovely equation. This one's got decimals in it, but have no fear, they work the same way. And let's see what values we wanted to try. So over here, let's go with some smaller values, 0, 1, 2, 3, and 4. So what's 0 times 2.3? That's 0 plus 6.1, that's 6.1. 2.3 times 1 is 2.3 plus 6.1, that's going to be 8.4. And then 2.3 times 2 should be 4.6. 4.6 plus 6.1 should equal 10.7. For this next one here, we have 2.3 times 3. That's 6.9 plus the 6.1. That's going to be 13 exactly. And then 2.3 times 4, it's going to be 9.2 plus the 6.1. That's going to be 15.3. So along here, 1, 2, 3. I'll just do 1, 2, 3, 4, and 5. And let's see, going up here, I guess we can do 2, 4, 6, 8, 10, 12. Nope. I guess I'll go by 4s. 4, 8, 12, 16, 20. So these decimals are going to be maybe a little bit tricky. So 0, 6.1. Well, 6 is halfway, but 0.1 is slightly higher. 1, 8.4. It's 10, 9. Doing a real rough estimate here. That seems pretty close. 2, 10.7. So 10's in the middle, 11's there. So it's a little bit off, but I think that's good. I think this one's actually a little high. Oops. That seems a little bit more. 3, 13. 13 is a quarter of a box over here. And then 4, 15.3. That's pretty high up in this box, closer to 16. Alrighty. There is our graph for number 18. Okay. Did a little bit more rounding and estimating maybe for number 18 just because the decimals are a little bit trickier. Okay. Cool. For these last few, we're going to switch gears. We're going to go ahead and now try to figure out the rule based on looking at a table. So for 19, I'm going to come with a table here, and then we're going to graph. So right away with the table, let's see what we have here. For 19, we have 0, 1, 2, 3, 4, 1, 2, 3, 4. And then we have 5, 6, 7, 8, 9. And let's see. We need an equation and we need a graph. So looks like the numbers are getting bigger by +5. So y equals x plus 5. Okay, I think that's it for the linear equation. And then we can go ahead and put a 1 and a 2, a 3 and a 4. We can put a 5 here. And then let's go maybe 2, 4, 6, 8, 10. So 0, 5 is here, 1, 6 is here, 2, 7 is here, 3, 8 is here, and 4, 9 is here. So we came up with an equation and we made a graph. And there we go. There's 19. Let's check 20. 20, we need what? A table. We need space for a graph. I guess a little bit more space is good. For 20, we have 0, 2, 4, 6, 8, 2, 4, 6, 8. And then we have 0, 6, 12, 18, 24. So it looks like all the x's are being multiplied by 3, right? So y is equal to 3x. We can call this 2, call this 4, call this 6, call this 8. Let's just go by 6's. Make it easy. 6, 12, 18, 24, and 30. So 0, 0 is here. 2, 6 is here. 4, 12, 6, 18, and 8, 24. Cool. That's number 20. Let's try 21. We have a table. We need space for an equation. I'll put a graph. So for 21, we have 0, 1, 2, 3, 4. We have -1, +1, 3, 5, 7. For this equation, looks like if you double all the x's and then take away 1, it works. Check it out. But it definitely does. I just checked it again. 1, 2, 3, 4, and 5. Oh, we need to go down here, don't we? Do we have space for 1, 2, 3, 4, 5, 6? No, we don't. I'll call this -2. I'll call this 2. I can draw that better. It's here, 2, 4, 6, and 8. So 0, -1 is here. 1, 1 is here. 2, 3 is up here. 3, 5 is here. And 4, 7. Cool. There's 21. 22. Let's see what we got here. Here's a table. Space for a graph and an equation. For 22, let's go with 0, 1, 2, 3, and 4. 2, 5, 8, 11, 14. 1, 2, 3, 4, 5. If we go to 14 here, let's go 3, 6, 9, 12, 15. So 0, 2 is here. 1, 5 is here. 2, 8 is up here. 3, 11 is up here. 4, 14 is up here. Cool. Little graph. Let's try 23. 23, let's throw a table in here. Cool. Leave space for an equation. 23, let's go with 0, 3, 6, 9, 12. And then for the y values for this one, let's go with 0, 1, 2, 3, 4. 0, 1, 2, 3, and 4. So it looks like each of the x's becomes smaller. They're divided by 3, but the same thing as dividing by 3 is timesing by 1/3. So we want to make sure we use multiplication for a coefficient. And then we'll go 3, 6, 9, 12, 15. And let's just go 1, 2, 3, and 4. And so 0, 0 is here, 3, 1, 6, 2, 9, 3, 12, 4. Because we spaced it out this way, it looks like it's just going across diagonally of these boxes, but the scale is different than before. 24. For 24, let's go with 16, 19, 22, 25, and 28. Some big numbers. And I'll go with 9, 12, 15, 18, 21. Looks like these numbers are getting smaller by 7, right? So we can say y equals x minus 7. That seems right. And maybe I'll go 4, 8, 12, 16, 20, 24, 28 to get all those x's. And then can I go by 3's here or no? 3, 6, 9, 12, 15, 18. Just short. Go by 5's. 5, 10, 15, 20, 25. 16, 9 should be right around here. 19, 12 should be about here. 22, 15 here. 25, 18 somewhere around here. 28, 21 roughly here. There we go. There's 24. 25. We got an equation, sorry, table, space for an equation. And maybe while we're at it, I'll put 26 right next to it. Dun, dun, dun. So for 25, what do we have? 0, 2, 4, 6, 8, 2, 5, 8, 11, 14. For 26, we have 6, 12, 18, 24, 30. And then we have 3, 7, 11, 15, 19. So for number 25 here, let's see, we're going to have y is equal to, I know there's going to be an x over here and a plus 2 because of the 0 and the 2. I think the other part is going to be, maybe 3 halves. I think 3 halves is right. If you take 3 halves and multiply by each one and then add 2, you will get each of the y values. Cool. So over here, let's see, we have to go to 8. So let's go 2, 4, 6, 8, 10. We have to go to 14 here. So let's go maybe 2, 4, 6, 8, 10, 12. I'll go by 3s. 3, 6, 9, 12, 15. So 0, 2 is located here. 2, 5 is up here. 4, 8 right up here. 6, 11 right up here. And then 8, 14. Cool, there we go. That would be the graph here, okay? And for this last one, for 26, I'm gonna say y is equal to something x. If I drop 6 on the x, that'll be 0. And if I drop 4 on the y, that'll be -1. So I think there's gonna be a -1 in here. And then, let's see, I think it's gonna be 2/3 of every x value. 2/3 of every x value. Yep, I think that does work. Okay, cool. These ones are a little bit more challenging, so you got to play around with it for a bit. So this is obviously just kind of helping to give you a bit of a key to help out with it. But you can play around with that and use some strategies that we've talked about in class, or if not, we could talk a little bit about it more as well in person. So that's me 30, 36, and then y goes up to 19. So I don't know, I'm thinking 4, 8, 12, 16, 20. 6, 3 is roughly here. 12, 7's up here. 18, 11 is here. 24, 15 is here. And then 30, 19 is up here. Cool. This would be the graph roughly for this linear equation. And just like that. And there you have 26 different practice problems dealing with some linear equations. So right from the beginning, what did we do? We talked about just some independent and dependent variables, just trying to remember and hopefully strengthen your understanding of like which one would depend on the other one. And then when we got to number 9, we had some tables to fill in given the linear equation, and then we plotted those points on a coordinate plane. So just a little bit of practice spacing some things out using our multiples and using our reasoning in terms of like how to space things out. And then once we got a little bit further down, then we went backwards, right? So once we got to, I think, number 19, we started with a table and we tried to look for the pattern and come up with the equation. So that's what we did there. I think actually I forgot to write the equation for 22. So I think that'll be y is equal to, I think each of these are doing what? I think there's a +2 in all of these. And then I think it's times 3. So I think it's 3 times each of the numbers +2. Yep, I think that's right. Cool. So again, these ones take a little bit more practice in terms of like trying to figure out the rule. And I totally understand if 25 and 26, those rules are a little bit trickier because of the fractions. And so if you try using whole numbers and you're stuck in the beginning, then maybe think about using some fractions. But they take a little bit more practice. So hopefully this was helpful. And as always, keep up the great work, and I'll see you in the next one.